There are only three types of loops in C, and we've seen all of them. They are of course the for loop, the while loop, and the do while loop. Now this module is entitled Special Loops. In this module we don't actually introduce any new types of loops, because there aren't any. All we do is learn about some special things that you can do with the existing loops that you already know about. The two different types of special loops that we're going to look at are the nested loop and the forever loop. A nested loop is a loop that is inside the body of another loop. A loop within a loop, if you like. So if you had a loop in your program that executed, say, 10 times, and then inside that loop, inside the statements that comprise the body of that loop, you had another loop, and that inner loop executed, say, each time through the big loop, the little inside loop executed 20 times, then the number of times that the statements inside the inner loop would get executed would be 20 times 10, in other words 200 times. So that's essentially what a nested loop is. We'll have a look at an example of that in a moment. Then we have the forever loop. How's the best way to describe a forever loop? Well, I guess you could say that it's like a controlled infinite loop. We mentioned infinite loops in an earlier module, and we suggested that you make sure that you never ever do them. Well, now I'm going to show you some ways that you can implement what could almost be called infinite loops but aren't quite. And I'll show you some good reasons for doing exactly that. Let's have a look at them. We'll start with nested loops. This is nested.c. It's a very simple program that has a loop inside a loop. Here is our outer for loop, which simply counts from I equals 1 to I equals 5, going up by 1 each time. Now, the only code that we execute inside that loop is this code here. And this code is itself a loop that counts from j. Notice there's got a different counter here. Here we've got I counting up, and here we've got j counting up. You've really got to make sure that you make them different, or you can run into all sorts of trouble. A common way to get from that line to that line, most programmers just do a copy and paste, and then they forget to change the i's on that line into j's, and they introduce all sorts of bugs into their code. Never mind. So we've got an outer loop that executes 5 times, and we've got an inner loop that executes 3 times for each one of the outer loop. So how many times do you think we're going to hit that printf statement? Well, you guessed it, it's going to be 3 times 5, which is 15. That printf statement is designed to show you the values of the loop counters I and j. So theoretically we should get I being equal to 1 for a while, and then j running through its values 1, 2 and 3, then I moving on to 2, and then j having 1, 2 and 3, then I moving up to 3, and so on. Let's see if it does exactly that. Let's compile. Let's run. And so here we are. I equals 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5. And each time through it's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So in other words, there's a total of 5 lots of 3, or 15. It's a fairly straightforward extension of loops, which is just loops within loops. But you might wonder, when would this ever be used? Well, as we're going to see in a later chapter, loops are used extensively with what we call arrays. And nested loops are used with what we call multi-dimensional arrays. For example, here we have 2 sets of loops, so that would be used with a 2-dimensional array. I know that you don't know what any of those things are at the moment, but don't worry, you will. Now we examine the forever loop. What I'll do is I'll take one of our earlier examples and I'll gradually modify it until we end up with what I would call a forever loop. Once we've done that, I'll explain the reasons why I would choose a forever loop over what we started with. So let's have a look at this code here. I hope you recall it. It's where we choose whether something should be an album or a single. And you may also recall that there was something that I didn't like about this code. Can you remember what it is? Yes, it's the fact that there is duplicated code. Here we have a reasonably complex condition, and here we have exactly the same condition all over again. Now admittedly that's not very much duplication, but it's the principle of the matter, and this is a particular piece of duplication that can be avoided, and so I would like to do so. So the first thing I'm going to show you is how to avoid it in this particular case. Well, I'm going to change my while loop into a for loop. That's being done because forever loops are only of the type for loop. They're not actually while loops. It's a forever loop, not a while ever loop. Now, in order to turn that into a for loop, I obviously need to put in an initialization statement, say something like that, and then some kind of increment statement, like that. The only question is, well, what goes there? What goes in the xxx's? Do we have any initialization or increment? Well, in this case we don't. So, now you probably didn't know this, but it's actually quite okay not to have an initialization or an increment in a for loop. Now, that doesn't mean that you can't have the semicolons. The semicolons absolutely have to be there. So it's like we still have three things inside the parentheses, except that two of them are blank. That is perfectly acceptable. So what we've written so far is absolutely no different to what we had before. But now I'll take it one step further. I'm not only going to have a blank initialization and a blank increment, I'm going to have a blank condition as well. Gone. In fact, I'm just going to have that. Two semicolons inside parentheses. So this basically means a for loop that has no initialization, no increment, and no condition. And if it has no condition, that means that it's going to loop around forever and never stop. In other words, it's going to be an infinite loop. What I've written so far has absolutely no way of ever stopping. So clearly I'm not quite finished yet. So, let's cast our minds back and see if we can remember another way to get out of a loop. Can you recall from the last module? There is another way to get out of a loop, any type of loop, a for loop or a while loop. Can you remember what it is? Yep, it's the break statement. So clearly, if I put a break statement somewhere inside this infinite loop, it would then break out, and it would no longer be an infinite loop. It would be, in fact, under my terminology, a forever loop, because this line here shows that there is no condition. And my definition of a forever loop is a loop that has no termination condition. So, under what circumstances would we break out of the loop? Well, looking at this particular loop, the reason that we would break out of this loop is if they ever typed in the correct answer. So let's modify this such that that would be a valid condition for us. So if they typed an A or an S, then we could break at that point. Does that look reasonable? So if they break at that point, then if we are to proceed to the next line, then the user must not have typed an A or an S. So that is a condition under which we can put out an error and go back around to the top of the loop. So I have now changed this loop subtly. It's no longer an infinite loop, but it is still a forever loop, in that there is a way to get out of the loop. And the way to get out of the loop is if the user types in an A or an S. So, I've now virtually completed my modifications to this particular loop. Have I improved it at all? Well, I've gotten rid of the duplication. There is now only one line on which the condition is specified. In fact, there's absolutely no duplication of code whatsoever. So I've achieved my objective. However, there is one little efficiency point that I might want to make here, and that is that this line of code here is setting a variable called album. An album is actually not referred to at all. The variable called album is not referred to at all inside the loop. The only time album is referred to is down here, outside the loop. So it is perfectly okay for me to take that line of code and put it down here. Now the reason I've done that is because this line of code is now guaranteed to only get executed once, whereas if I put it up in here, somewhere up in here, then that line of code would get executed each time through the loop. So it could conceivably get executed 100 times, which in this particular code, if you think about it, is completely unnecessary. It's a minor point, but I just thought I'd make it anyway. Now, we have constructed for ourselves a reasonably efficient piece of code with no duplication. Is it better than what we started with? Well, it is better if you don't mind using a forever construct and you don't mind using a break construct. Well, they're both part of the C language, they're both valid C syntax, so there's no reason not to use them. Many programmers do, you may as well get used to them. Incidentally, it is actually possible at times to write yourself a real infinite loop. a loop that has absolutely no way of getting out of it. Why might you do that? Surely you want every program to eventually finish. Well, that's not necessarily true. There is a certain class of program, known as daemons in Unix or known as services in Windows, that really just, you never want them to exit. They're started at the beginning of the system and they continue processing just over and over and over again, doing the same thing over and over. In other words, they loop until when? Well, until the system shuts down, at which point they stop. So if you're going to write one of these particular programs, then it's perfectly acceptable to write an infinite loop. And when the system shuts down, your program will terminate, and of course then your loop will stop. So to write one of these, you would simply create a main, and somewhere inside the main you would have a for loop, which looks like this, a forever loop. You could actually write it slightly differently. There's another way to write a forever loop, which I don't like quite so much, which looks like that, while 1. That will of course perform exactly the same functionality. It will loop forever, except it's slightly less efficient. The reason being is that each time through the loop 1 has to be compared with the value true to see if it's true or not. And it will be, of course, every time, so that's why the loop will continue, but it's the actual comparison that has to be performed. The forever loop, which is this line here, doesn't have any comparison like that, and so that's why I prefer it. Okay, well that just wraps it up for special loops.